Okay, excited that you're all here. I'm going to get right into it. We got a lot of content to get to. Talk about JRuby 10 and some of the cool optimizations that we're working on. Thank you. First of all, for my friend Mufan, I want to promote the RubyConf Taiwan 2025 combined with CUSCUP, the open source conference in Taiwan. So if you want to know more about it, just find this guy. He will tell you everything about it, and hopefully I'll be able to see you there. Okay, konnichiwa. I'm very excited to be back here and present JRuby 10 today. There's my basic contact information. I have been developing and maintaining JRuby for 20 years now, trying to bring the best of the Java platform to the Ruby world. It says unemployed here. Last year, I was working for Red Hat, and they were sponsoring the project, but after 12 years, they decided to move on from that. So really, right now, I just work for the Ruby community. I am continuing to do JRuby development full-time, funding the project through sponsorships from users and through support contracts for folks that have critical production applications running on JRuby. And so far, we are managing to maintain development, maintain me as one developer, but looking for new opportunities to partner with companies out there. So please let me know if you think you can help the project or if you need a little extra help deploying or profiling code. So the big announcement this week, we finally released JRuby 10. This is our biggest release in many, many years. We have jumped to Ruby 3.4 compatibility, running lots of new tests and specs, thousands of new assertions. We've done a lot of work to try and make sure compatibility is solid. We also now require the minimum of Java 21, because of all the cool new features in the JVM that we want to start taking advantage of, that when we run on an old version, it was just too hard for us to utilize them. So lots of additional performance work coming up this year. So the talk is optimizing JRuby, but that means a lot of different things, and different things to different people. Of course, as Rubyists, we know Ruby is optimized for developer happiness, and JRuby is just another Ruby. We want it to feel and work just like the Ruby you use every day, the standard C Ruby. But there's other ways that we can optimize JRuby in the community. We can optimize by giving you more opportunities to use Ruby in more places. We have compatibility work that we continue to do and try to speed up our adoption of new features. We've been working hard on improving startup and warm-up time, which are traditionally hard things on the JVM. We've also worked on various kinds of direct performance, straight line performance, multi-core. And I'm going to go through each of these areas a little bit and show you what we're doing in JRuby. So compatibility-wise, tracking Ruby updates, Ruby versions is a very challenging project. It's the #1 thing that we have to work on all the time, maintaining compatibility, fixing compatibility issues with regular Ruby. The big leap that we've made with JRuby 10 to Ruby 3.4 means that we're finally caught up again. If we look at what this is on a chart here, C Ruby versions are the blue line there, increasing pretty much linearly, except for example, the jump from 2.7 to 3.0. And you can see JRuby varies a little bit. We fall a little bit behind, we miss a release or two, and then we catch up again. And then we fall a little bit behind and we catch up again. That's because of the work required to maintain compatibility with each release means we won't be able to do optimization. We won't be able to support users. So sometimes we have to balance those things. Another way to look at this, how many days of lag time it's taken JRuby versions to catch up with C Ruby versions. So here are along the bottom the versions of Ruby that JRuby has supported: 2.2, 2.3, 2.5, 2.6, 3.1, and now 3.4. And you can see the 3.4 block is the smallest one. This is the closest we have ever been to being right on schedule with supporting the current version of Ruby. And actually, we probably could have released JRuby 10 in December, but we wanted to complete some stabilization, make sure there were as many tests running green as possible. So we're very excited to be caught up with C Ruby again. And this work is all done by the JRuby team, of course, with some external contributors. If we look at contributors to CRuby who have done more than 20 commits in the last year, we have a long list of developers. Of course, Patch Monster, Nobu, is right up at the top, as always, but lots of other folks from Shopify and from other companies all contributing to CRuby. On the JRuby side, it's a little different. It's largely me, and then Tom does a lot of work on the parser. He does a lot of work with users and supporting issues. And actually, the number 3 committer on the JRuby project is my son, who's in the audience, who did all of the work on the new JRuby launcher and has helped us out with some of the C and native code that we have for JRuby as well. Obviously, we need more help here. More folks that can try things out, help us implement new features. You can implement them in Ruby if you want. We're fine with that. But keeping up with Ruby is a big challenge for us because it's not a very big team. So what about Rails 8 compatibility? Well, this is complicated, and I've answered this question multiple times this week. In general, everything that's pure Ruby in Rails, we expect to work from version to version. So Rails 8 requires Ruby 3.2. Now we have JRuby 10, which supports Ruby 3.4. Everything Ruby-based in Rails ought to work just fine on JRuby. Now I say that most things work, because then we have something like Active Record. Almost all of the work we have to do to be compatible with Rails is updating our version of Active Record. There's a lot of special code specific to all the database adapters. There are database-specific things that we need to translate over to the Java Database API. This is where most of the lag comes from. So I don't know how many people are running Rails and using other persistence layers, but Active Record is pretty much the only thing that we ever have to work on to keep up with compatibility in Rails. And again, we would love to have some help here. Folks that are familiar with the database adapters in Active Record can help us keep up on JRuby's side. So, startup. This is one of the first things that people run into with JRuby. And first impressions are important. We want JRuby to feel as close to CRuby as a development experience as possible. Unfortunately, there's a lot of work that has to be done to get JRuby up and running. All of our code starts out as Java bytecode or Ruby source files. All that code has to be parsed in, loaded by the JVM. The JVM has to run it for a while, and then it will optimize it to native code. And that whole process takes a while just to get things up and running. So we've been exploring some of the new features coming along in the JDK to help speed up our startup time, and later on it will also help with warm-up time. A little graphic example, there's a lot of steps to JRuby. Our design of internal IR, our intermediate representation, is very similar to what we have in the ZJIT JIT that's coming for CRuby and 3.5 and beyond. And the JVM itself actually has the same sort of compiler design. So our code runs for a while in our interpreter, we feed it into the JVM runs it for a while, and then we eventually get very fast native code out the other end. And so a lot of the work we do is trying to shorten this process as much as possible. So on the JVM side, the exciting projects that we've been looking at lately, first off, application class data store called AppCDS. This is a feature that came along around Java 17 or so. It allows the JVM to preload and pre-cache all of that parsed code, all of the metadata, the methods, the class data, all of that, so that we can jump right in and not have to reparse all that stuff every time when we start up. This is the primary way that we've been getting some improvements lately. Coming in the future and available as a preview in Java 24 is machine code caching. And that's a project called Project Layden, and they have an AOT cache feature. So as Maxime mentioned in her talk, ideally when we generate optimized native code, we won't have to do that over and over again if we restart. That's exactly what this is going to do for the JVM. We will be able to run some example code, save off the optimized native code that's generated from all of your Ruby, and then hopefully jump right back in to a fast executing runtime. There's also a more unusual approach to this, coordinated restore at checkpoint, or Project Crack. What this actually allows us to do is save off an entire process, its memory space, its execution, everything, and then quickly restore it and jump right back to that point in execution. Only supports Linux right now, so it's fairly limited, and there are some other limitations, but this does some amazing things with startup. So let's take a look at a comparison here. We've got our JRuby on the left. Optimized for developer happiness often means optimized for startup, so it's very quick to get going. And then we have plain old JRuby 9.4. So significantly slower, and this is a noticeable pain for developers on earlier versions of JRuby. We do have a special flag you can pass, --dev, that will reduce the amount of optimizations we do, reduce what the JVM does, and that gives us a little bit improvement. But now in JRuby 10, taking advantage of app_cds, the baseline is already almost as fast as --dev, and the --dev flag brings it down even more. So now we're starting to get back under a second for startup time on basic things. We've also played with early versions of the AOT cache. That's improving things too, and there are dozens of engineers that are working on that for JDK right now. And then Project Crack. As you might imagine, if we can jump right back into a running process, it's very fast. And if it works for your application, this is an excellent way to get up and running immediately with JRuby. So there are solutions for startup. So let's talk about straight line performance, optimizing the performance of how we run Ruby code. JRuby really depends on the JVM to do most of the heavy lifting. As I mentioned, the JVM itself has a SSA compiler design similar to what's in ZJIT, but with 30+ years of engineers working on this, dozens of engineers across the world. So it's really, really good at doing these optimizations. JRuby has its own IR and its own basic block compilation. We feed that into the JVM, trying to do a little bit of optimization on our side and try to explain to the JVM how to make Ruby code fast. So let's look at an example here. Pure Ruby red-black tree benchmark basically builds up a tree, does some traversal, does some removals, and then we benchmark how long it takes to do all of that. JRuby 3.4, able to do about 15 iterations per second of this benchmark. Now, of course, we love YJIT, and we're very happy it's speeding up Ruby. This also does a great job of optimizing on the JRuby side. Some of this comes from more direct access to instance variables, reduced overhead of doing calls. But JRuby actually still is faster than YJIT. And that's without me looking at this benchmark for many years. So a pretty typical piece of pure Ruby code, JRuby should generally run it faster than Ruby without YJIT and even Ruby with YJIT. Now, we also have an advantage here because if you write a native extension for JRuby, they can't optimize through that. They can't optimize it with all the other code. And so C extensions are a hard barrier for optimizing code in Ruby. And as we know, there are a lot of C extensions, and we've heard many of the JIT team from Shopify talk about how difficult it is to make those optimize well. This is an example of JRuby running the OJ extension, which is a pure C or pure Java JSON parser. And in every case, JRuby is able to run this extension much faster, even though it's just a plain code port from the original C code. We're able to inline it with Ruby code. We're able to feed it to the JVM. The JVM does a better job of optimizing at runtime than just the plain C code can do. So actually running ported C code faster on the JVM because of all of these optimizations. Now, fibers have become more and more important in the Ruby community, and we've had some traditional challenges here. Fibers were not well supported on most older JVMs. The only way that we could implement fibers for JRuby was by wrapping full native threads. And native threads have a lot of limitations that aren't compatible with fibers. We can only spin up a couple thousand per process generally. They have much bigger memory overhead. They have a lot of cost at the kernel level to even get started and prepare all the metadata for them. So it was almost impossible for us to keep up with the number of fibers that something like Async, Falcon, and some of the new frameworks want to use. Luckily though, we have Project Loom on OpenJDK, which has now brought lightweight fibers to the JVM in the form of what they call virtual threads. So if we look at a little benchmark here of spinning up 1,000 fibers, make sure they're all actually started and running, and then resume them so they'll all finish. With our native thread version, where it was just a regular operating system thread, only getting about 49 iterations per second on this benchmark. With the virtual thread implementation in the JVM, many times faster already. And this could be much, much more. I have to do some work inside JRuby to reduce the cost of creating a fiber, and this is going to get much, much faster, very likely going to be faster than CRuby very soon now. We also heard from Aaron Patterson about optimizing class new when we want to allocate a new object. He showed his optimization where it can inline the allocate plus the initialize and improve performance significantly. JRuby actually implemented this almost 10 years ago, and we've taken advantage of it because the JVM can then inline, the JVM can optimize, and we can do a much better job of allocating objects quickly. So if we look at a few small benchmarks here, doing a bunch of object new, how fast can we just allocate a plain object? We have CRuby 3.4 with YJIT getting about 10.3 million iterations per second, or object allocations per second. The patch that Aaron came up with, giving about a 30% increase, which is about the same as what he showed in his talk. So 13 million object allocations per second. But then there's JRuby 10. So this is very much the JVM doing an incredible job of inlining object allocations for us, making them low cost, making them fast, and all we have to do is teach it the allocate, initialize, the little dance that we have to do for object instantiation. And actually this may be a little easier to see if we go to a logarithmic scale here, so we'll stay with that for a moment. Now, I was actually surprised how fast this was, so I took one of the JVM profilers and hooked it up to my JRuby instance just to make sure it is actually allocating those foo objects. They're actually being created, they're actually on the stack, or they're actually on the heap. It's just that the JVM does such a good job of optimizing that process, we get the benefit. So let's look at the actual foo class. So here, let's have a Ruby-based initialize. Now you'd expect that this would slow things down. Now we have to have the Ruby call to initialize. It's not just going to be the default native initialize anymore. But again, we have our object new allocations versus foo on Ruby 3.4. The optimization that Aaron came up with, opt new, and JRuby has basically no impact by writing that initialize in Ruby. We still end up being significantly faster to allocate objects, and because of the great garbage collection on the JVM, those objects can be cleaned up much faster than any of the ones that are available for CRuby right now. There's also another advantage here. The fact that we're inlining the object allocation, inlining all of that new logic, means we can get more advantage out of newer JVM JIT compilers, like the Graal JIT. Graal is very good at eliminating allocations that aren't actually needed. So if we run our foo benchmark on there, we run with regular Java 21, we get 216 million allocations per second. Graal sees that we're actually not using a whole lot of these objects and eliminates most of them. So when you have code that is using a little object temporarily and then throwing it away, we may not even allocate it if you have the right JIT compiler running underneath it. This is the advantage of the JVM being able to inline and optimize all the way through that code. So data was also introduced in 3.2. It's a new feature for us. Hopefully some of you have been using it because it's a very nice design. It's a new immutable struct type. It's got compact storage, so it's not using standard instance variables. It's a little bit lighter weight. And it has a special new method that kind of does that same process, allocate and initialize all at once, and gives you an immutable object back that has the data in it. So here we have our bar class, which is defined as a data. That should be data.define. And then we'll just allocate it quickly with 3 values here. We have CRuby 3.4 with YJIT, getting about 2.9 million. Aaron's patch doesn't really apply here because it's not the default class new anymore. It's a special new for data. So this is about as good as you can get on current CRuby. You run it on JRuby, we're getting almost 3 times the performance again. And it's just because the JVM is able to optimize those objects much better. So another area here, optimizing concurrency. We continue to hear lots about Ractors and how they're going to bring real concurrency to Ruby. I believe it's possible that Ractors can do that and can make it possible to use all the cores in your system, but writing Ractor-friendly code is pretty challenging, and even the Ruby core team is still struggling with the core and the standard library to make sure all of that can work in Ractors. There's also a high overhead crossing over that Ractor boundary. You have to make sure that these objects are shareable. You have to make sure they're frozen. Potentially that means you need to be doing more allocation to pass clean objects across that boundary, and so you lose a lot of the benefit. In JRuby, you can just use threads. If you are using thread-safe code, you pass those objects off to another thread. You can actually utilize all the cores in the system without making any major changes to your application. So a little benchmark contributed by Masha here. We played around with doing threads versus Ractors to see what kind of performance we'd get on CRuby versus JRuby. So for a certain number of threads, we're going to spin them up. They're going to sit and wait on a queue to get data, to get work to do. When they get that work, they're going to parse that JSON, and then we'll deal with it later. So here is the benchmark. If we're running with threads, we're just going to feed chunks of that data into the threads, let them chew on it and parse it. Otherwise, we'll just do it in a linear way. So we look at this, we're looking at improvement by using threads versus Ractors here. So CRuby running with threads gets a slight improvement. Not a whole lot. This probably is, there's a little bit of back-end stuff. There's a few places where the lock can be released for parts of JSON, but most of the time, you're not getting the full benefit of those threads and the cores on your system. Now, this is actually an old number. This is current Ruby 3.4. When you try to run this same thing with Ractors, it actually slows down. The overhead of crossing that Ractor boundary takes away all of the performance benefits you have and actually introduces a lot more overhead. But this is being patched. It has been improved in a recent patch that just came through today. So now we're up to like a 1.3 times improvement. And I should note, this is all on my system, which has 4 cores. So ideally, we'd be expecting that we see a 4x improvement by spreading it out across threads. And of course, when we run it on JRuby, real threads, that's actually what we get. The same code running on CRuby versus JRuby, you will see all the cores light up, you'll max out your system, and you can do all of your parallel processing in a single process. This also translates to applications like Rails. Here is a graph showing how many requests per second you can get per megabyte of memory you throw at the application. In CRuby, to get concurrency in Rails, you need more processes. Each process is going to have its own garbage collector. It's going to have a lot of its own data. You're going to be doing a lot of duplicate operations and duplicate round trips to the database. You don't get as much of a gain by throwing all those processes. With JRuby, you can have a single process run your entire site. And there's a crossover point where we use so much less memory than CRuby that you're getting much better requests per second for the resources that you're paying for. All right, and so kind of a final area that I wanted to mention, we have the optimizing of opportunities for Ruby to be used in the world. JRuby runs anywhere that Java runs, which of course is just about everywhere. Rubyists can take the knowledge that they have, take their Rails applications and their libraries that they've created. You can deploy them in a Java shop. You can package them up as a single binary and ship it as a commercial piece of software. All of these things that are still an open problem in the Ruby world, you can go to the JVM community, you can go to these big enterprises and start using Ruby to build applications today. I've talked with 2 or 3 different people today, this week while we've been at the conference, who have actually packaged up Rails apps, deployed them in a Java organization, and nobody ever knew they were writing Ruby. You can bring Ruby anywhere that Java can go. A little example here is using the Java Swing library, which is the GUI library that's built into the JDK. We create a frame, we add a button to it, we set up an action listener for the click event that will just change the text of the button. Then we add the button to the frame, we display the whole thing. Now we see our window will pop up. When we click on the button, it goes back, it runs our Ruby event handler, and it does what we expect it to do. So with a very small amount of Ruby code and any available JDK, you can build a graphical application that runs across platform very easily. And of course, this extends to other things. Shoes 4 is based on JRuby, and it gets the advantage of built-in graphical libraries. Glimmer is a much more professional API for building user interfaces that can run on JRuby using another toolkit called SWT. Of course, it wouldn't be a JRuby talk without showing some of the Minecraft plugin abilities here. This is a plugin written in Ruby for Minecraft that just changes the number of chickens that come out of an egg. But all written in Ruby, all plugged into the JVM because we all just live under that same runtime. And of course, Android is largely Java-based, so we do have a framework for building Android applications in Ruby. It's called Rubato, and here we have a couple different examples of using an interactive IRB session within an Android application, loading up scripts and running them. And there actually are commercial users out there who use JRuby on Android for point-of-sale devices, ad terminals, all sorts of other applications. So, looking at JRuby's future here. So, JRuby 10.x, the maintenance versions that we've got coming up in the next year. Lots more optimizations coming. Now that we have the release out the door, I've got a long list of things that I know we can do better. I know we can optimize more completely. For example, keyword arguments are still a little bit slow. We still allocate a hash. The JVM is good at getting rid of some of those allocations, but ideally, if we don't need to create a whole hash to pass keyword arguments, we shouldn't do that. So that's one of the first things I'm going to be working on. If you find a specific case that's slower in JRuby than it is in CRuby, let me know, because there's probably something wrong in JRuby that I can fix. We're also going to be exploring all of these different JDK features like AOT cache to improve startup, Project Panama to make optimized native calls from Ruby code so that our FFI is faster. And really, it's just kind of going to be a matter of upgrading your JVM. You upgrade the JVM, you get better garbage collectors, better JIT, cool new features, and your Ruby code runs faster, and you don't have to do anything else. So the other side of this, I need the Ruby community to help me keep helping you. I really believe JRuby can solve many of the problems that the Ruby community has, performance-wise, getting it into difficult enterprise organizations. If JRuby goes away, I think Ruby would be immeasurably damaged. This is an opportunity for us to expand Ruby into a much larger world, to be able to do high performance, high concurrency processing of data all over the world, just using the Ruby that we love to use. So please, I would love for you to try JRuby. Let me know how I can help you, scale it, profile it, optimize your code. And if you do use JRuby, please, let's talk about some sort of partnership where I can help you run your application better and you can help the JRuby community stay healthy. So, thank you. Domo arigatou gozaimasu. I will have JRuby office hours after this. You can find me. And if you come by with an interesting problem to solve, maybe I'll give you one of the American IPAs I brought with me. But I also have stickers and business cards for anyone who wants them. Thank you.